Hello, Internet. Alright, let's talk about the chain rule. So let's write chain rule in white. Oops. Let's see. Let's zoom in a bit. Chain rule. Multivariable function. Multivariable version. Multivariable variable. Now, what is the multivariable chain rule? Now, recall that in single variable calculus, the chain rule is essentially taking if f of x is a function of some other function g of x, for example, when you differentiate f of x, you differentiate f of x as f prime of x, but you have to differentiate the the inner function the inner function, which is g of x, which is used as its input or parameter. So you have to differentiate g of x as well. So let me write this in a very separate, very not separate, but well, yes, separate what do you call this? Separate syntax or form, whatever mathematicians call it. Right, so let's do it in this color. So f of g of x is the same. It's equal to df of dg times dg dx. Now, this is this is going to be kind of our basis of the basis of my explanation to how it may or may not make sense. So let's so this is I have trouble speaking. So this is, of course, the variable version of the chain rule. Now let's go up a notch and do multivariable chain rule. So multivariable chain rule looks something like this. So assume that f of the function f is a function of of three inputs or three parameters with x, y, and z, and both x, y, and z, all, not both, there's three. So all x, y, and z are functions of t. So they are a function of t. So notice the similarities. This and this. F, the function f is taking as inputs as inputs functions of an independent variable. So let's write the chain rule. So let's say df dt. So let's say we want to differentiate f with respect to t. So the answer or the formula is going to be partial f with respect to partial x times dx dt. Similar to this. Let me switch colors. Yellow, yes, yellow. Similar to this. Now, df partial f partial y times dy dt. dy dt, this is not a partial, not partial, not partial, because it's only a function of a single variable. And then we have plus this bad boy, df dz times dz dt. So that is the multivariable chain rule. And it has several applications, like in neural networks, machine learning. There is an algorithm to minimize the loss function in supervised learning, which is backpropagation, which uses the chain rule as its basis. Chain rule. All right. See you in the next.